Hi everyone, how are you all? Okay, so I think you can hear me, right? Great. Can you just tell me if audio is fine? If audio is fine, then we will just start. Okay, so if audio is fine, then we will just start. So, hi everyone, how are you doing? Yes, we will be discussing many of the questions. Okay, yes, synchronization we will be discussing. Okay, so this is part one solution, and I will be taking part one. Part two will be taken by Deepak sir, right? Okay, great. So let's get started. I hope you people have enjoyed AIMT 3, right? Okay. अखिलेश इज सेइंग सर रिजल्ट के बाद सेशन होता तो ज़्यादा लोग आते सो डोंट वरी अखिलेश एक्चुअली result is published at 10 p.m. and it will be little late, so that's why we thought that we can make it early. Okay, so let's get started. Let's just start with the questions directly. Now this is the question number 11. So few of the questions I will be solving, and in the next part Deepak sir will be solving the rest of the questions. Okay, so I hope you can see this question, right? So maybe I can just adjust my video frame little bit. Okay. Okay, so here I hope that is fine. So this is question number 11. Now let's just start this question 11. Let's just start discussing this. So this question was related to scheduling, which was comparatively, I guess, easy question. Okay, so in this question they are saying assume the shortest remaining time first, which is SRTF scheduler for the original workload, and this is the table that has been given. Now similar kind of question was also there in the previous mock test. Do you recall? The similar kind of question was there in the previous mock test also. Do you recall that? Okay, mostly some of you people might recall. Otherwise, that is fine, right? So, by the way, what was your answer of this question? Tell me your answer. Okay, you people are saying C. Yes, C is the correct answer. So let's just see this question. Okay, okay. Is this buffering? Is this not clear, or let me know quickly. Okay, is this buffering? Okay, so okay, it is buffering little bit. Okay, so okay, no audio. Some people are saying no audio. In the previous watch time, okay, no, not buffering. Okay, okay, it is not buffering. Okay, great. If there is any issue, okay, if there is any issue with audio or video, you can just let me know quickly. Okay, okay. If there is any issue with audio or video, you can just let me know quickly. So now you people are saying 3 seconds is the answer. Yes, 3 seconds is actually correct answer. It's very easy question. Okay, so they have given ABC. Now they're asking what is the longest CPU burst could be. So longest CPU burst could be to preempt the jobs that was running at 8.5. Okay, so let's just see this question. So basically A is running from 0 to 2, and now B has come. So I can just quickly tell you that, see, A is coming at 0. So A is running at 0 to 2. So from 0 to 2 A is running, and now after that B has come at 2, and B wants to run till 6, right? So B is running till 6. Why? Because B it is shortest job first. So basically if B CPU time is 4, then it is the shortest at this moment, right? Because A remaining time is 6 only, right? It is 6 only. So now because of this 4, it will run, and in between this will come, that is fine. Now this is 7, this is 6. So basically A will get scheduled again, and since its remaining time is 6, it wants to run till 11, sorry, 12, right? So A wants to run till 12, but they are saying that at 8.5 means here, right? At 8.5, what should be the longest, okay, what should be the highest job, okay, such that it can preempt A. So A remaining time at 8.5 will be how much? A remaining time will be 2.5, right? A remaining time at yeah, it will be 2.5, right? Or 3.5. So 8.5 and 2.5 is basically 11.0. Okay, so it will be 3.5, right? So what was your answer? So since it is 3.5, okay, so that is the reason. Remaining since remaining is 3.5. Now if someone with lesser than 3.5, whatever it comes, right, with lesser than 3.5, whatever it comes, then it will preempt A. Okay, So 1 can preempt A, 2 can preempt A, 3 can also preempt. But they are saying what is the longest that can preempt A. Okay. So basically C. So that is why this C, which is 3 seconds, is the correct answer here, right? Okay. Is this understood to everyone? Let me know. Or there is any doubt here. Okay, great. Now let's just move to the next question. So in this next question, this was very interesting question. How many of you got the correct answer? By the way, you don't know the answer. First of all, tell me the answer. Okay. First of all, tell me what was your answer. Okay. First of all, tell me what was your answer for this question. See, in this question, they are saying let x be the length of shortest path from S to E. Okay, from S to E, x is the length, right? X is the length. Okay, let me use another color. S to E, x is the length. And now they are saying, I mean, you can easily see that this is the shortest, right? I mean, this is the shortest. Why? Because S to C, there are like two ways, and obviously you will be going like this, right? You will be going like this, right? And then C to E also two ways, then obviously you will be going like this. So this is the way to reach, right? 3 plus 3, 6, 7, 8, 9. So this x is very clear, and this is 9, right? X is very clear. Okay. And what was x? X is this. This is x. Okay. This way is x. Now what about y? Now notice here they're asking number of spanning trees. Now interestingly, they are not asking, okay, they are not asking number of minimum spanning trees. See, this is very interesting question because they are not asking number of minimum spanning trees. Yes, many of you people have gotten it correctly, but they are not asking, okay, they are asking different spanning trees. So see here, the Prashant is saying silly mistake, okay, and took spanning tree as minimum spanning tree and got 10, which is wrong. Yes. So basically here they are saying different spanning trees. How many of you remember that this kind of things, different spanning trees, these kind of things we have done in the class? In Go classes lectures also we have done this thing. See, in gate also they might ask these things, right? They might miss these things. And also this is standard university question. Okay, I mean, I have not taken this question from myself, although it is like a standard question, I could have taken from myself also. But yes, actually this question, as it is question, let me just tell you the source also. As it is question is given at standard university, and they were also asking, okay, so at this university this question was given, and they were also asking spanning trees. They were not asking minimum spanning tree. I mean, actually in this particular link they were asking spanning and minimum spanning both. Okay, so how many spanning trees are there? Can you tell me how many spanning trees are there? Different spanning trees. See, for this particular thing, how many spanning trees, and for this particular thing, how many spanning trees? So you know, if in case of loop, it is very easy to find out spanning trees. Why? Because since it is loop of 4 edges, and then you want to skip this just one of that, right? So don't worry about the weight. Whatever weight is written, that is fine, because you should not worrying about it, because they are asking about spanning tree, not the minimum spanning tree. So you can skip this, or you can skip this, or you can skip this, or you can skip this. So basically there are 4 ways in this particular cycle, or in this particular loop. There are four ways to get a spanning tree. There are 3 ways to get a spanning tree, right? So 4 into 3, which is 12, is the answer for y. Okay, 12 is y. So 12 plus or maybe 9 plus 12, which is x plus y, which is 21, is correct answer here. Okay. So see, many people are saying that okay, many people are saying they have done a minimum spanning tree, which is fine. Okay, this is how we are learning, right? Okay, this is a learning phase. So see, many people are saying, for example, yes. So see, these people are anyway giving very nice answers, which is 12 for buy. Okay. So someone, for example, Ankit's model is saying MST hota to easy hota. Crick lovers, he is saying that I solve for minimum spanning. Many people are saying such things, right? And this is the reason for this question. This question was have put for the same reason. Okay. Got it. And the exact same question I have taken from this particular link. Okay, there is no modification. I have taken exact same question. They were also asking about the spanning trees. They were not asking about the minimum spanning tree. Exact same question from this university. Okay, it was easy enough. But you should be very much particular about these things. They may ask about maximum spanning tree. Okay, they may also ask about maximum spanning tree, right? They may definitely ask about maximum spanning tree. In that case, what you will be doing, you will take the maximum edges. Okay, just like minimum edges, you will take first max, second max, third max, like that, right? So they can definitely ask. So don't assume that they will always be asking minimum spanning tree. Okay. Okay, now let's move to the next question. Right now, let's move to the next question. See, this is basically a screenshot from that link. Okay, so they were actually asking about length of the shortest path that is fine. Different spanning trees are 12. Different minimum spanning trees is just one. Okay, minimum spanning tree is just one. And what is the weight of minimum spanning tree? It is 11. Okay, so these four questions they were asking at that original link. Okay, at original link. Right, I have taken this one and this one. So this was x I have taken, and this was y I have taken. Okay, I have taken these two only. Yes. So Deepak is saying that so this comment is by Deepak. So Deepak is saying that spanning tree देख के minimum spanning tree समझा गया. Okay, you can read this in Puspa voice. Okay, now let's see this question. This was again easy but interesting question at the same time. Okay, easy but interesting. Right, so in this question they are saying that suppose that we have sorted list of n unique integers and we have two integers. See, they're saying we have already the sorted list, right? And we had two integers, right, at the end of this list. So suppose you already have the sorted list 1 2 3. I mean, you can have any numbers, but without loss of generality, which means, I mean, whatever numbers you have doesn't matter. You can always take 1 2 3 4 5, right? Now you want to add two more numbers at the end, right? So suppose this and this. Now they are saying that what is the exact least and greatest possible number of inversions in the updated list. So what could be the least one? Least one can obviously be 0, right? I mean, you can have 6 7, right? Least could obviously be 0. So least is very easy. Least is 0. What could be the greatest? Greatest could be such that this number is having inversion with all. Okay, this is n numbers. So, and this number is having inversion with all, and these two numbers are also having inversion with each other. So n inversion, the first one is having inversion with all, second one is also having inversion with all, and these two are also having inversion with each other. So for example, like with this you will be having 2n plus 1 inversions at max. Okay, at max you will be having 2n plus 1 inversions, right? So 0 to 2n plus 1. Yes, right? So least is 0 and greatest is 2n plus 1. So I think C is correct answer here. Okay, is this understood to everyone? Let me know if there is any doubt here. Okay, it was easy one, I think, right? Now let's just move to the next question. So what was your answer of this question? Tell me, what was your answer of this question? Okay, okay, so you got 30, right? Okay, so some of you have got 30. Okay, so basically 30 is correct answer. That's correct. Okay, 30 is indeed the correct answer, right? 30 is the correct answer. So let's just see this question. This question is also easy one. Let's just see this question. So what they are saying, they are having n next. So n is given something like this, and they are saying n next. So n next means what? See, n is pointing to this particular thing, right? N next is actually this, right? I mean, n next, if I just print, let's suppose if I print, okay, print n next. So it will print this address. So let's suppose it is keeping 1000. So it will print 1000. Okay, so n next is this particular thing, right? And now you are having two more time next. Okay, if you do one more time next, you will be having this particular address. Now its data, so its next is this, its data is actually 30, right? Its data is actually 30. So this is the thing, which is the whole thing, and next, this is the thing, right? And its data is actually 30. So that is why C is correct answer here. Okay, C is correct answer here. Is this understood to everyone or not? Okay. Okay, so I hope that is understood, right? Great. Yes, C is correct answer. Now let's just move to this question 15. What was your answer? Just tell me quickly, and then we will proceed to the correct solution. What was your answer? Yes, yes. So I think C was the correct answer here, right? C was the correct answer. Let's just see this question. Let Cx be the number of leaves in a binary tree rooted at T. Okay, Edge leaf t returns 1 if t is leaf. Okay, if t is t, I mean tree, that root is itself leaf, then it will return 1. Which of the following observation leads to the recursive implementation, right? So cx, basically they are saying the number of leaves rooted at t. Okay, so I think it should be ct most probably. Okay, so that's fine, it should be ct. So ct is the number of leaves rooted at t. Okay, great. Now let's just see this. So they are saying number of leaves they are asking, right? Okay, so number of leaves will be number of leaves in left and number of leaves in right. Is this correct? Is this correct? So what you people are getting? Are you people getting A, B or C? Okay, this is some confusion that is happening. Some people are saying A, some people are saying B, some people are saying C. Okay, so what this option A is saying, let's just see step by step. What this option A is saying? Option A is saying CT B, number of leaves in left. Okay, number of leaves in left plus number of leaves in right. Okay, is this even giving you the correct answer for if there is only one node? Is this even giving you the correct answer if there is only one node? Because for this left, number of leaves will be 0. For this, number of leaves will be 0. 0 plus 0. Is this giving the correct answer? Tell me. No, right? Okay. What about B? What about B? Can I do just plus 1? Can I do just plus 1? I mean, in the left, in the right, and then plus 1. Can I do plus 1? Is it always plus 1 possible? See, if it is a root, then in the left, in the right, I will be adding, but should I be adding the plus 1? No, right? I mean, if it is not a leaf, so it should not be plus 1. If it is not a leaf, that is the catch here. If it is not a leaf, it could not be plus 1. Right? Now see this thing, if you observe, this thing is common in all the options, right? You just have to observe like whether should be plus 1 or should not be anything. It should be edge leaf t or something like that, right? So this is anyway common. I mean, number of leaves in left, number of leaves in right. Right? Now in the recursive implementation, what will happen? If you do plus 1, you will be adding even if it is not leaf. If you do edge leaf t, if it is leaf, okay, then only you should be adding 1. Right? Then only you should be adding 1. You should not be adding 1 always. So see, you should not be adding 1 always. So that is why these two options are anyway false. B and D are anyway false because you should not be adding 1 always, right? You should be adding 1 only when this is a leaf, only when you have reached to the to the end. Okay, so for the leaf, okay, for the leaf it will return this is 0, this is 0, and edge leaf is actually 1, right? Edge leaf is actually 1. They're just asking the recursive implementation. So that's why C is the correct answer here. Okay. So C is correct answer here. Why? Because plus 1 should not be there. Because you should not be adding plus 1 always. And you should be adding something. Otherwise just, it will not be basically returning even true for even just one leaf node, right? So that is why this C is the correct answer. That if it is leaf, then only you add 1. Right? You keep on going to the left and right. Okay, you keep on going to the left and right, and on the left and on the right, and whenever you reach the leaf, then only add 1. Right? Then automatically these will be actually false. Right? Automatically these will be false. I mean, these will be 0. Okay, if you reach the leaf, then only add 1. Right? So basically how it will run? See here. So how many leaves you have here? You have 4 leaves, right? You have 4 leaves. Now you just run this, okay? You will first go here. You will say, okay, go to the left, go to number of, C T dot left plus C T dot right plus 1, right? And then this is C T. Okay, this is CT equal to something like this, right? Now, for this particular tree, it should return 4. Sorry, this is edge leaf. What is that? Edge leaf, right? Edge leaf, okay. Edge leaf of T, right? Yes. So For this particular tree, this should return 4. Let's just check. Okay, you will go to the left and then you will add right. Let's just see what this left is returning, right? What this left is returning. For the left, you will say, okay, let me go to the left, right? For this, you will say, okay, let me go to the left. It is 0 0 and right is also 0, right? And is this a leaf? Yes. So it will return 1, right? It will return 1. So this for this t left will return 1, this will return 1, and this will return 0, right? So basically for this t dot left, it will return 2, because 1, see, everything is doing 3 calls, right? Left, right, and edge leaf. Edge leaf will return 0 for all of this. Okay, see, this is interesting where I'm saying that edge leaf will return 0 for this. Okay, 0. So let me write 0. 0, edge leaf will return 0 for these two and this also, right? Left will return 1 for this, 1 for this, and edge leaf will return 0 for this. So totally it will say 2, right? It will also say 2. So similarly it will say 2 plus 2 plus 0, which is 4, is the correct answer here. Okay, understood? Yes, some of you might have felt that this particular mock test was easier, right? Some of you might have felt that way, right? That this particular mock test was easier, which is fine, right? But yes, there is a chance of silly mistakes also. See, in gate also they ask easier basically questions, right? They ask easier questions, and in those easier questions you might end up doing some silly mistakes. So yes, it might be easier, right? Many people felt that same way, it might be easier. But there are chance of the silly mistakes in those papers. So I think from last 1-2 years, okay, from last 1-2 years, they are asking easy papers only, but still people were doing mistakes. So we have kept in that same way. Okay, maybe AIMT4, maybe we can make it moderate. Okay, we can make it moderate level. AIMT4 could be a moderate level, right? We can make it. Yes, definitely we will be having 4 and 5. Okay, if you people want, we can have 6 also, right? It will depend on you guys. So but yes, 4 and 5 will definitely be there. Okay, so I mean, so basically, I'm not 100% discuss with this with Deepak, but yes, I'm telling with my guts because we have time. Okay, and we can easily accommodate 4 and 5. So that's why I'm saying that 4 and 5 we will be having. Okay, so what was the answer of this question for you guys? This was easy question or tough question? How did you feel about this question? What was your answer? So they are asking that this was question about Aloha, right? So by the way, what was your answer? Let me first check your answer. Okay, some people are saying sir tough banao, tough banao. Yes, we can definitely do it, right? So Hers is saying maybe we can go with something like this. Okay, Hers is saying sir AIMT4 should be moderate, right? AIMT4 should be moderate, and AIMT4 should be hard, and AIMT4 5 should be moderate. So most probably we can do something like this. Okay. Now let's just see this question. This is question number 16. What was your answer, by the way? Okay, you people have got B as an answer. Let's just see what this question is saying. Consider the nodes in the slotted Aloha with each slot. In each slot, you are transmitting with the probability P, right? In each slot, you are transmitting with the probability P. Suppose that a given channel has exactly 8 nodes. Okay. What is the probability that there is a collision on a given slot? Okay. If there are exactly 8 nodes which wants to transmit. Okay. So let's suppose these are the 8 nodes. What is the probability that there is a collision in the given slot? So when there will be a collision, can you tell me when there will be a collision? How to solve this question? Whenever 2 or more stations transmit at the same time. Okay, so probability at collision is same as whenever 2 or more stations transmit, right? So this is the probability of collision. So I can easily say this is 1 minus either one station transmit or no station transmit. I mean 1 minus, you can do plus, or maybe I can directly do, or no station transmit. right? This is something like this. Is this okay to everyone? Now this is same as 1 minus 1 station transmit. What is the probability of 1 station transmitting? You can select one, I mean 8C1, okay, 8C1, and I mean this is just a which theorem you will be applying here? Bernoulli theorem, right? Okay, so you will, or Bernoulli random variable or something like this. I mean you don't need to worry about the probability, but I mean distribution, but I'm just telling you, you can think in that way also. Okay, so is this okay that one station is transmitting and none other station is transmitting, minus no station transmit? What is the probability that no station transmit? 1 minus p is the probability of not transmitting, and not any station is not transmitting. So this is the probability. So finally this is the probability that you are getting, right? So what is the correct answer here? Sorry, yeah, binomial, not Bernoulli, binomial. Okay, yes, so I think B is the correct answer, right? Understood. So I hope this question was also easy one, right? Great. Now let's just see this question number 17. Let's just see what this question is doing. Suppose you are a network operator with internet service provider ISP, and your ISP has two customer networks, IIT Bombay and ISC, right? For the sake of simplicity, let's name that IIT Bombay has three hosts with these IP addresses, and ISC has two hosts with these IP addresses. You have heard that memory in your router line card is expensive, and you would like to use as few entries as possible in your line card. Okay, so in your routing table, you want to basically have as few entries as possible. Your colleague at work says that he has a solution that only requires two forwarding entries, right? So, given the hyperprefix notation, your colleague uses to represent these two networks. So, what is your answer here? Okay, you people are getting A as an answer, right? Yes, actually, A is the correct answer here, right? So, should I solve it, or I think this is easy enough? Maybe you can just repeat. Okay, let me just solve it. It's not an issue. Okay, so maybe I can just represent 112 in the binary. Okay, or maybe I do not need to even represent. You can just check here that here this 18 and 18 and 18 is same, but because of this 255, right? So you can just say that only initial 8 bits 8 bits are fixed. Only initial 8 bits are fixed. I mean, you can have backslash 8, right? You can have backslash 8. Okay, if you just want to use two forwarding entries, so backslash 8 is the best way to supernet it, and then you will say okay, uh, okay, so backslash 8, right? So 18.0, I think this is the correct answer, backslash 8. So backslash 8 is given only in option A, but let's just see other options also. I mean, let's just see this also. So here you are saying that this is 112, 128.112. Till this point it is fixed, and this is 0, this is 255. So basically this is backslash 16. Till backslash 16 it is fixed. So that's why A is the correct answer here, right? Okay, so I hope that is understood to everyone. Okay, that's not very tough question, that's easy question only. I hope you people have understood this. Great. Now let's just move to the next question. Next question is basically, computer networking question only. So by the way, this had mixed, 1 mark and 2 mark was mixed here. 1 mark and 2 mark was mixed. Okay. So this is not based on question number that it is 1 mark or 2 mark, right? So because 1 mark and 2 mark was mixed in this particular AIMT. Okay. So let's just see this question. What they're saying that what is the use of ARP protocol? What is the use of ARP protocol? What is the answer of this question? Tell me quickly. Okay, D, right? D is the answer of this question. To determine hardware address of the given IP address. Yes. So basically what do we do with the ARP? We say that suppose this is, some router and it wants to send to some host within its own network, right? Its own network. Then it only knows IP. It will say that, okay, this is the IP of the host. Then can you tell me the MAC address? So it sends ARP packet, right? To determine the hardware address or the MAC address with the given IP address. So that's why D is the correct answer here. It's also easy question. Okay, Karthik is saying that then D वाले like करें और B वाले सब्सक्राइब करें. Nice one. नहीं, उल्टा कर देते हैं. बी वाले बी वाले लाइक कर दें डी वाले सब्सक्राइब कर दें, क्योंकि होपफुली डी वाले ज़्यादा होंगे. ओके, so let's just go to the next question. So in this question they are saying that fx equal to k has three real solution. So basically this is the plot of fx that is given to you, right? Now which line is cutting it three times? So it's very easy, a straightforward question. So I think -3, right? -3 is cutting it three times, so that's why -3 is correct answer. So D is correct answer here. What was your answer? Okay, D is correct answer. कार्तिकेय की भी मान लो यार, मतलब अगर लाइक नहीं किया तो लाइक कर दो, बिकॉज दैट इज हाउ यूट्यूब एल्गोरिथम विल वर्क, राइट? देन ओनली यूट्यूब विल रिकमेंड AIMTs टू other people also, right? Okay, now let's see this question. What was your answer of this question? This is question number 20. What was your answer? Now in this question they are saying the language they are producing, okay, either this or this language they are producing is actually same. Language wise there is no difference between G1, G2, G3. So they are saying language is same, right? Maybe the grammars are different, right? This is G1, this is G2, this is G3. Maybe the grammars are different. Now they are saying which of the following is or are true. So this is question number 20, right? So what was your answer for this question? Okay, so let me first check your answer. You are saying A only. Okay, let's just see what is the real answer. So yes, A and D were the answers. Okay, so maybe this particular option was little tricky. Language generated by these grammar is LL1. Okay, so see here, like, okay, let me first tell about the grammar and then I will tell you about the language. Okay, so by the way, what do you understand from the language? Okay, can anyone tell me? Can anyone tell me what do you understand by the language? See, these are the three grammars, right? So let me first tell you this is LL1 grammar actually. How to check it? You can make the parsing table, right? So let's just make LL1 parsing table and let's just see this particular question with the help of the parsing table, right? So if you draw the parsing table of LL1, then it will look like this. Let me just tell you parsing table of LL1. So for G1 it looks like this. Okay, for G1 it looks like this, right? So here you will say that, okay, for any of this entry there is no kind of, you can say, there is no conflict, right? So that is why this is definitely LL1 grammar. This is definitely LL1. What about this one? If you check this, then here this particular, this particular is differing from this in the sense that here you have BAB, right? So let's just make the parsing table of this. Okay, so where will this as gives goes to? It will go to, you will say that whatever the first of capital A, right? So first of capital A is basically epsilon also and B also. So as gives O will go to B and then in follow of capital A, right? So capital A follows again B. So yes, so as gives A will go here only, right? So that is fine. Maybe I can just draw this nicely. So now I'm drawing for G2. Okay, now I'm drawing for G2. Okay, so let's just suppose this is production number 1, this is production number 2, this is production number 3. Okay, so now you tell me what will go under B, what will go under dollar, what will go under, I mean, in these two rows. Okay, so see here, you will be sending, okay, you will be sending S to A under the first of capital A, right? Under the first of capital A. What is the first of capital A? Epsilon and B. So by the way, if it is B, then you will be sending to B. I mean, you will be sending S to A here, and since it is epsilon also, so you will be going to the follow of capital A, and this is also B, so that is fine, right? Now, what about this A to epsilon? What about A to epsilon? This will go to. Can anyone tell me quickly? This will go to which place? This A to epsilon. Just tell me quickly. Okay. So maybe I can just open it up. I think I have closed that streaming. Okay. So if epsilon is replaced with VB, then parcel will confuse what to take. Yes. So first tell me that this particular production A to epsilon will go at which place? This will go under where? Follow of A, right? Okay, follow of A. So this will go to follow of A, which is basically B, right? So it will, and follow of A is also dollar, right? Follow of A is also dollar. Okay. So basically, you can see here that follow of A is also dollar, right? I mean, follow of A is same as follow of S, and which is also dollar. So this particular production will go to uh, follow. I mean, this particular production will go to first of A, which is basically epsilon. So that is why this particular production will also go here, right? S gives $8. Okay. What about this? A gives epsilon. What about this? This will go to follow of A, right? What is the follow of A? Follow of A is small b and dollar. So two number will go here and two number will small b and dollar, right? Will go here also. What about this? This will go to first of A. So first of A is basically small b. So it will three number will go here also. So basically, if you have A in the hand and if you want to produce a small b, then you will be confused, right? You will be confused whether to use this or to directly use this. So that is the reason this is having the conflict basically. Okay. So here is the conflict. So that is why this is not LL1, right? This is not LL1. Similarly, here also the follow of A is B also. I mean, here it will also go and this will also go. So here also this is not LL1, right? So that is why you will say that only G1 is LL1. Okay, only G1 is LL1. Now language generated by these grammar. So language is fixed, right? I mean, all of them are generating the same language, right? So how to, anyone has solved this correctly? Let me know. Anyone has solved this correctly about the language part? So what is the language that these people are generating? What is the language? That is a regular language, right? Okay, so see, the language that this is generating is basically, you can say, at least double B will be there, right? So I think it will be BB and then BB star, right? Because it can also generate epsilon. Okay, so it will be BB star. So this is regular language. Is this okay to everyone? This is regular language. Now, for every regular language, there is a regular grammar. So there is a regular grammar also, right? I mean, if there is a regular language, then there is a regular grammar. Is this fine to everyone? And if grammar is LL1, then if it is having regular grammar, so basically, actually, if they are asking language generated by this grammar is LL1, so you can say it. What does this mean? It means that it can be whatever language you are generating, it can be recognized by the LL1 parser, right? So this particular language is basically regular language, and you already have one of the grammar which is LL1, right? You already have one of the grammar which is LL1. So they are saying language generated by this grammar is LL1. What does this mean? It means that there is LL1 grammar for, see, maybe I can just go to the next page. Okay, I can just tell you in this way. See, suppose you have this. Okay, let's suppose you have just G2. Let's not worry about the other grammars. Suppose you have just G2. Okay, is this generating, is this LL1 grammar? Is this LL1 grammar? Then answer is big no, right? We have seen this. Now tell me, is this generating LL1 language? Then answer is yes. Why? Why that is the case? Because there is because there is a corresponding LL1 language for the grammar. Corresponding LL1 grammar for the language. Right? And what is that corresponding grammar? Corresponding LL1 grammar? What is that corresponding LL1 grammar? G1. We have already seen this, right? So we have already seen this, that G1 is the corresponding LL1 grammar. Okay. Is this understood to everyone? Yes, these things were discussed in the class. Someone is asking, sir, can we convert this into LL1 grammar while left factoring? Yes, you can do. I mean, you can do whatever you want to do as long as you have. I mean, there's the if I mean, as long as you have the language preserved. If the language is not changing and you have the corresponding grammar, okay, whatever you want to do, you can convert it to the corresponding grammar, and whatever grammar you have, it should give you. Okay, let's suppose this is G star. It should give you the same language. If that is the case, okay, and if this G star is LL1, if G star is LL1, then you will say this is basically LL1 grammar. So by the way, sorry, this is LL1 language. Okay. So by the way, this particular question, this type of question, I think has been asked in GATE also, and this particular question I have taken from Standard University. Most probably, I will put the link on the GATE flow. Most probably, it is Stanford. Okay, I don't currently have the link. But I will search it because I have taken this question from Standard University. Most probably it is Stanford. Okay, maybe I can just search for the link. Give me a second. Okay, so let me quickly check if I can find the link. If I don't find currently, then I will definitely put it later on. Okay. Okay, so maybe I will just put it later on because it might take some time for me to find out, right? So, but these kind of questions has been asked in GATE also. Okay, someone is asking LL1 grammar should be unambiguous left. So they are asking about the language. That is the thing. Again and again, they are asking about the language. Okay, see how to see whether this language is LL1 or not. Okay, so how to see this? You have some grammar which is may not be LL1. That is fine. Okay, that is fine. Okay, the grammar may not be LL1, but what if you have, see, if you have the corresponding language here. Okay, let's suppose this is the grammar G. If this LG have a different grammar, okay, let's suppose this language is shared by I mean, this is having some language which is LG, right? And this is same as some other LG star, okay, for some other G star, okay, and then the G star happens to be this G star happens to be LL1. This is definitely possible, right? I mean, this is not LL1. Okay, this is not LL1, but its language is same as, okay, is same as G star language, and G star is LL1. I mean, basically, what do I mean to say? That you can have another grammar having the same language, okay, having the same language. If this grammar is LL1, then you will say that this language is at least LL1. So how to say a language is LL1? How to say language is LL1? If you have at least one LL1 grammar, okay, if you have at least one LLM grammar for that language. Okay, is this understood to everyone? Okay. See, that's what I'm saying. That if it is regular, okay. I mean, see here it is directly given, but even this is not given. Okay, even this G2 is only given. Then can you answer this question if only G2 is given? See, here it is very much hint. Okay, here in this question we have made it easier by giving you the hint, but only G2 is given. Then what will you do? So in this case, you can say that this language is at least regular. From here, can you make a comment? So can you say the regular grammar for every regular grammar is LL1? So maybe I can just put you one question that has already been asked in GATE. So have you solved this question, by the way? GATE 2007 question. Have you solved this question? Have you solved this question? Every regular grammar is LL1. This GATE 2007 question. So what is the answer of this question, by the way? What is the answer of this question? So I mean regular grammar need not to be LL1, by the way. For example, you can definitely have, for example, C and CC, right? This is basically left recursive. And this is regular, right? It is regular. So it is not LL1. But every regular language, okay, SAT means language, okay? I mean SAT and language are same thing basically. LNGAGE, every regular language has corresponding LL1 grammar. This is interesting. Is this true or false? So tell me. So see, every regular language have every regular language have regular grammar which is left factor, right? Which is left factor, and also that particular grammar is actually okay. This is LR1. In fact, if it is LL1, then also it is true, right? In fact, if it is LL1, then also it is true. Okay, so every regular language has some regular grammar, and we can represent every regular grammar with at least one LL1 grammar. Okay, for LL1 also it is true. Okay, anyway, you solve this question, you will get more clarity about this concept. Okay, so this is false, this is true. Okay, so solve these kind of questions in compiler, and then you will get more clarity. Okay, now let's just see this question. What was the answer of this question? What was the answer of this question? So in this question, they are saying that P is pointing to A3, and then P plus equal to 2, which means now P is pointing to 5, right? And now star P plus equal to 2, which means now this particular value is 7. And now you are printing star P plus plus. Although you are first doing, see, plus, I mean, you always go to the right, or in other words, this plus plus have the higher, precedence. So, or you, in these cases, you always go go to the right, okay? I mean, there is one trick that I have already told in the goclasses lectures. You always go to the right. But it is postfix, right? It is postfix. So since it is postfix, although it will happen, but it will happen in the next line. You will first do star P. Star P is 7, right? And in the next line, the postfix will happen. So that is why B is the correct answer here. Okay. How many of you have done B? Okay. B is the correct answer here, right? See, plus plus. Now let's suppose after this also I have printf star P. Then in this case, P is printing here, and now 6 will get printed. Suppose there are two prints, right? Then first 7 will get print because of this, and now 6 will get print because of this. Okay, suppose there are two prints. Okay, great. Now find the inverse of this matrix. So were you able to do this? So what was answer of this question? What did you get? Let me know your answer quickly. So this is question number 22. I mean, in your examination, because the question was shuffled and it was in random order. So maybe you have not seen this as question number 22. But yes, this is question number 22, right? So see here, for the by the way, answer is D. But some of you people might have done mistake, right? Because of the some short trick. Okay, see. Okay, so one of the short trick to find the inverse is that you exchange these two. Okay, for 2 by 2 matrix, you exchange these two and you put minus symbol here. Okay, you put minus symbol here, but you have to always divide with the determinant. Okay, you also have to divide with the determinant. Okay, so that is why D is the correct answer, right? Now let's move to the next question. So in this question, they are saying that the number of sets in two independent cache C1 and C2 is same. C1 is to be associated with cache 32 bytes block. Okay, so C1 is to be associative, which means each set is having two blocks, right? And number of sets are same. Suppose number of sets are n in both cases. Okay, so there are n sets. So what is the size of C1? It will be n sets. Each set is having two blocks, and one block size is basically one block size is 32 bytes, right? 32. What about C2? For C2 also, number of sets are same, but it is 8-way associative and one block size is 256, right? So these are the sizes of C1 and C2. Now they are saying what is the ratio? I mean, how many times it is bigger? So this is 2 power 6, this is 2 power 8, this is 2 power 3, so this is 2 power 11. So 2 power 5 times it is bigger, right? 2 power 5 times. So what was your answer? Yes, 32 was your answer. Okay. So you also got 32 as an answer. Great. Yes, 32 is correct answer here. Okay. Now let's move to the next question. So for this question, what was your answer? So they are saying that x is 2.25, right? Now, okay, let me just tell you the answer. So first tell me what was your answer. That was very easy question, by the way. Okay, that was extremely easy question. So you can just convert 2.25 into binary and then you can solve this question easily. For example, see here that 2.25 will be written as 10 because it is 2, and 0.25 will be 1 by 4, which is 0.04, right? 0.01. So basically this is 2.25. You will represent it in the scientific notation, something like this, right? And then you will say, okay, your asked question is basically about the mantissa. So this is mantissa, right? This is mantissa. Now if you are writing implicit one, then with the implicit one, this is mantissa. So A is the correct answer here. Okay. So implicit one shown. So they are saying implicitly one you should be writing. Okay. Implicit one should be there. So that is why A is correct answer, not B. Okay. Implicit one should be there. Now let's just check this question. This was good and interesting question. What was your answer for this question? This was a good question, to be honest. What was your answer? Okay. Okay. You people have got A, right? You people have got A. Let's just see this particular question. So what they are saying, for this particular question, they are saying, yes, A is the actually correct answer. Okay. A is actually correct answer. Great. For this question, what they are saying that I is less than y, I plus equal to 1, I equal to x, and then break. See here, they are saying that it will break if I is less than 1 or I is less than y, or it will break if you reaches x, right? I mean, you are incrementing 1 by 1. The moment you reaches x, it will break. Otherwise it will break anyway on y, right? So basically if I is greater than y, if I is greater than equal to y, then it will break. Okay, so let's suppose, let me take a value. Let's suppose x is 10, y is 5. Okay, x is larger. Okay, let's suppose x is larger, then it will break on y. Okay, so it will keep on incrementing it, and if x is larger, then it will, I mean, in all the options actually x is larger, right? So in all the options x is larger. Maybe one of the option I could have kept x as smaller, but that's fine, right? In all the options I have made x as larger because I don't want to make this question actually complicated. You know what, I have actually trimmed down this question. Do you want me to show the original version of this question? I mean, what was my initial thought about this question, and then what I finally gave you? Okay, so maybe currently, do I have that original version? Let me quickly check. Okay, so the original version was quite complicated. Yes, I have that original version. See, this was the original version where I was having j also. Okay, but I didn't want to make this particular question very tough, so that's why I just removed this j. Initially I had j also, and this was the original question. If you want, you can solve this question. Okay, if you want, you can solve this question. This was the original version of the question, and then we have made it easier. Does it look very scary? Okay. Yes. This is a good question to try. Maybe I can just tell you the answer also. Okay. In case if you want to, try in future. So just let me just tell you the answer of this particular question. Okay. That is MSQ question, by the way. And A and B are the answers. Okay. You can try this question later on. Let's see this question. This question was also easy one. Okay. Now what they are saying here, S is pointing to A, B, C, D. What was your answer of this question? What was your answer of this question? Tell me quickly. Okay, someone is asking, sir, please tell this question, this test was general gate level toughness or not? See, in GATE, they have mix type of examination. Sometimes they ask easy also, sometimes they ask tough also. So in GATE 2023 and 24, it was comparatively easy from last 2 years. That is why people are saying that okay, goclasses test series is hard, because see, in last 2 years paper has been very kind to you, but it need not to be always the case. So that's why we thought that okay, this is AIMT 3, we can make it similar to 23 or 24. It was on the easier side, to be honest, but gate also asks these things. Okay, gate also does these things, so don't worry about it, right? Gate also does these things. I mean, the competition is anyway fair, so you will be competing with many students in gate also. Here also you are competing with many students, so competition is anyway fair. If it is easy, then it is easy for all. If it is tough, then it is tough for all, right? Okay, now let's see this question. So S is pointing to A, B, C, D, E. A, B, C, D, E, right? And then there is a null, because this is double quotes, right? So there will be null, and this is a constant string. These things we have already discussed in our lecture. So basically this means A, B, C, D, E, and ending with null, right? Now they are saying that J equal to J plus Si. Okay, J is initialized with 0, Si minus A. Okay, if you subtract I is initially A, so if you subtract this A, then it will be J plus 0, right? So J equal to J plus 0, so J will be same as J, and I will be incremented to 1, right? Now J is 0 and I is 1 after one iteration. So initially J is 0, I is 0, but after one iteration, okay, this is the case when Si was Okay, si was a. Now you will be incrementing, since this will be basically going to b, so you will be incrementing this j by 1, right? So basically j equal to j plus 1, j equal to j plus 1, and I equal to anyway 2, right? So now j will be actually 1. Now j equal to j plus 2, right? And which means it was 1 earlier, so it will be 3, right? So basically it will be 3. Now j equal to j plus 4, right? So 3 plus 4, it will be 7, and it will go j equal to j plus 0, 1, 2, 3, 4, right? So basically it will be 0 plus 1 plus 2 plus 3 plus 4, 0, 1, 2, 3, 4, right? So 7, 8, 9, and 10, right? It will be 10, and I will be incremented till the length of this. Okay, 1, 2, 3, 4, 5. I is 5. So what is the answer of this question? This is easy question. What is the answer of this question? Okay. So what did you get for this particular question? I mean, I'm asking your answer. Yes, A is the correct answer. What did you solve? What did you attempt in the examination? Okay. So this question was related to dynamic programming, and what was your answer for this question? This was also a nice question, right? This was a nice question. So what was your answer of this question? Yeah, currently I'm at home. That is why it is a different background. Okay, currently I'm at home. Yes. So for this question, A was the correct answer. Okay, let's just see what they are saying. They are saying that if you want to, I mean, first of all, they are denoting D and J with number of ways. You can write n as sum of integers, right? For example, if you want to write D, if you want to write 5 comma, let's suppose 4, okay, where A an integer use at most once, okay. So basically 5 comma 4 means you are taking from A1 to A4, okay. So how you can represent this 5 using this A1 to A4? That is the question. So what you can do? You can do, if this is 1 2 3 4, you can do 5 equal to 2 plus 3. Okay. If this is from 1 2 3 4, how you can represent? You can represent 5 equal to 2 plus 3, or you can represent 1 plus 4. So there are two ways. So they are saying that is two ways. Okay. There are two ways to do it. Right. If you are using any integer exactly once. Now there are always two options. Okay. Given this, there are always two options. Either you take the last element. If you take the last element, then it will be something like this, j minus 1, if you take the last element, right? Or you don't take the last element. I mean, if you take the last element, then how many number of ways, right? Which is given like this. If you don't take the last element, then how many number of ways? If you don't take, then it will be just j minus 1, which is given like this, right? So this should be summation of these two, which means A is the correct answer here. Okay. Is this okay to everyone? Okay. This was easy question. How many of you felt it was easy? Actually, it was easy only, right? I mean, it was a simple dynamic programming question, simple DP question. Yes, it was easy. Okay. Now let's just move to the next question. So this question is saying that we have given a positive integer d with a set of frequencies 2 power d. Okay. So with the set of what is the set of frequencies for 2 power d characters? So number of characters are 2 power d, right? Where the optimal prefix code by default mean they are talking about Huffman code, because Huffman is optimal only, right? Huffman is optimal. I mean, there is no other technique which can produce better than Huffman. It is proven. Okay, it is proven thing. There is no other technique which can produce or better than Huffman, which is prefix code also. So optimal prefix code by default mean they are talking about Huffman. Okay, has an associated tree of depth d, exactly d. The depth is the length of path. Okay, so they are saying you have 2 power d characters. Now with these 2 power d characters, what you want a Hoffman tree having exactly d depth. Okay, so basically if these are the 2 power d characters, right? So each, see, if let's suppose, if these are the 2 power d characters, right? If let's suppose you have, I'm solving in the reverse way. If you have a tree, can you tell me a tree with depth d? Okay, tree with depth d. So suppose this is a tree with the depth 1. How many leaf nodes you have? 2 power 1. If it is tree with depth 2, how many leaf nodes you have? 2 power 2 leaf nodes, right? Here you have 2 power 2. If you have tree with left depth 3, how many leaf nodes you have? 2 power 3 nodes, right? So if you have, okay, if you want to have 2 power d leaf, because all of these characters has to be leaf, I mean they cannot be presented as an intermediate node in the Huffman, they have to be leaf. If you want 2 power d leaves, and then you want, and then you want d depth, right? I mean, see, you have now two conditions, because you have 2 power d characters, so you want 2 power d leaves, and you want d to be depth. You cannot have more than d depth. Okay, so these things are given in the question. I mean, there is nothing I have done. These, instead of leaves they have written characters, but I'm writing leaves because character is a leaf in Huffman, right? So this is given in the question. So it has to be the perfect tree, right? It has to be the perfect tree only. Okay, so every character will be on the leaf. It has to be the perfect tree only. Is this fine to you guys? It has to be perfect tree, because then only you will be having 2 power d in d depth. In d depth, if you want to accommodate 2 power d leaves, then that's the only way, right? If 2 power d leaves, if you can have more than d depth, then probably you can write some of the leaf here. Okay, I mean some of the leaves here maybe. Okay, if you can have, if you can have more than d depth, then you can have some other tree. But for this case this should be the only answer. So which means each of these characters should be having the same frequency, then only they have to be on the same level, right? So each of this character, if they are having the same frequency, then you can do something like this, right? So which is 1 upon 2 power d, right? Same frequency means 1 upon 2 power d, 1 upon n, right? Frequency should be equally divided. Okay, then only it is possible. So A is the correct answer here. Yes, yes. So these kind of questions determine your rank, that is for sure, right? These kind of questions determine your rank. So Murud Alam is saying that for those who are saying something like this, that these are the easy questions, but chances are that you can do silly mistakes and all. So by the way, congratulations for 23 and 32 rank, okay, for in AIMT 1 and 2. But yes, you are right that these kind of questions determine your rank. See, your rank will be determined by how much you know, not by the how much you don't know. Okay, if you can apply all the things that you know, then your rank will be automatically very good, right? Okay, let's see this question. These kind of heap question I have been asking in almost all the AIMTs. So what this question is saying: suppose that a binary min heap stores 6 elements with the priorities, okay, 10, 20, 30, 40, and 60. So 10, 20, 30, 40, 50, and 60. So basically this should be the structure. I'm just making the structure. Okay, this should be the structure of the min heap. What is the largest item that could be stored at A1 if indexing starts with A0? So see, minimum 10 should be here. What could be the largest item that could be here? Okay, what could be the largest you can put here? See, whatever you put here, since it is mini heap, so you have to put, see, on top of it, it should be minimum, right? So basically, or in other words, basically below it, it should be more and more, right? So two more elements, you can take 50 and 60, right? Now, apart from this, you can put anything. I mean, you can put definitely 40 here. Everything other than this, 10, 20, 30, whatever is remaining, it will get adjusted. I mean, you can definitely adjust on the right side. So basically, you need two elements, which is like greater than that. Can you put 50 here? No, because greater than that, you don't have two elements. You just have one element. So you need at least two element, which is 50 and 60. Greater than that, right? So 40 is definitely eligible. 30 is also eligible. 20 is also eligible. So 40 is the correct answer here. It is easy question, but some of you people have done it wrong, right? This was easy question. Okay, 40 was the correct answer. Yes. Some people have done 20. Okay. So see. Now let's see this question. This question is saying, suppose you wanted to insert the following elements into binary search tree of integers. Okay, so suppose you want to have binary search tree and you want to insert these elements. Which of the following insertion order will lead to the complete binary tree? Okay, so you need to just tell that which of the following will lead to the complete binary tree, means the tree which is fully filled except the last level, and last level is filled from left to right. Okay, we have defined what is the complete binary tree. So what was your answer for this question? What was your answer? So how many elements you have here? 1, 2, 3, 4, 5, 6, 7, right? So 7 elements you have here. Can I make the structure at least? 1, 2, 3, 4, 5, 3. 1, 2, 3, 4, 5, 6, 7. Yes. 1, 2, 3, 4, 5, 6, 7. Is this structure okay to everyone? Now you should be having something here which is basically, median, right? I mean, 3 element left of this, 3 element right of this. Okay, so which one is median? If you check here, then I think 16 is median here. Okay, you should be having 16 here, right? And whatever is the left of it, which is 3, 7 and 12, right? So 3, 7 and 12 should come here. Out of this 3, 7, 12, I mean, you can say that, okay, I mean, 16 must be, coming at first, and then out of this 3, 7, 12, 7 must be coming next, right? 7 must be coming next. Okay, 3 cannot be coming. Okay, before 3, I mean, among this 3 and 7, in between 3 and 7, 7 should be coming next, right? 3 cannot come first, then 7. So 7 could be coming first. 7 should be coming first. So I think 7. So that is why A is the correct answer. And the tree, there are multiple ways. Okay, out of 3 and 12, maybe you can exchange. Okay, I mean, 16, 7, 12 and 3 will also give you the same tree. Okay, there are multiple answers. And I think in one of the mock test, not at least if not in AIMT, in one of the mock tests, do you remember, I have asked that in how many ways we can insert that we will be getting this tree. How many of you remember that question? In how many ways we can insert such that we will be getting this tree? This kind of question we have asked, right? Let me know. Okay. Okay. Maybe some of you remember, maybe some of you don't remember. Okay, we have asked this kind of question. A complete BST is this only. Now 38 will be here, and 50 and then 90. Okay, this is the complete BST, but there are multiple possible ways to get this complete BST. Okay, since this is just MCQ, there was only one correct answer, but we can easily make it MSQ and we can have multiple correct answers, right? Okay, now let's just move to the next question. This is question number 42. What was your answer for this question? What was your answer for this question? Tell me. Yes, so answer for this question was B, right? Answer for this question was B. So let's just solve this question. That was, I think, doable question, easy question only. So can you tell me the file size? File size is 50,000, right? 50,000 packets. File size is 50,000 packets. And now, can you tell me number of packets? The maximum packet sizes in the network, which is 500 bytes, right? Number of packets is 100, right? Okay. So can you first tell me what is the transmission time? Transmission time will be how much? Length upon bandwidth. What is the length? Length is 500 byte of each packet. I'm calculating for a packet by packet, and bandwidth is given to us as 1 MB, right? 1 mega bits. So since it is in byte, let me convert that also to the byte, or maybe it to the bits. Okay, doesn't matter. So basically, let me multiply by 8, and then this is 1 into 10 to the power 6, right? Bits per second. So basically, finally, this will be 10 to the power 6, 10 to the power 3, 4000 seconds. Sorry, 4 bits per second, right? So it will be 4000 seconds. Or I'm doing basically it will be 4000. So this is 500 bytes, 1 megabyte, 1 megabit per second. Bandwidth is giving like this. Okay, so which question you are saying to explain? Okay, so maybe I can just resolve it. So basically, what is happening here? Length is length is 500 bytes divided by bandwidth, right? So what is the bandwidth that is given to us? The bit rate of all the links is 1 megabits. Okay, so 10 is power 6, it is mega and per second, right? So seconds means that is fine. So finally it will be in seconds. So but since it is in bytes, I can convert it to bits. Okay, okay. So finally it is 4 milliseconds only. Okay, sorry. So I think I was doing something wrong. Okay, this is not 4000. Okay, so this is 4 milliseconds, right? Yes. So finally it will be in the seconds, but if you convert into millisecond, you can convert definitely to the thousand, and finally it will be in the 4 milliseconds. Okay. So basically you can say the transmission time is 4 milliseconds. What about the propagation time? What is the propagation time you are getting? Propagation time is basically given to us as 10 milliseconds, right? Propagation time is 10 milliseconds. Transmission time is 4 milliseconds. Now, since there are like 17, right, or maybe 16 routers, so basically in between there are 16 routers, but it will also transmit. So you can say there are 17 transmissions will be happening, right? So 17 into 4, because 17 transmission will be happening for the data. And how many propagations will be happening? Similarly, 17 propagations will be happening for the data. This is for the data. Okay, data. And for ACK also, you won't be having the transmission time for ACK because it is given as negligible, right? Transmission is negligible, but anyway, it will be having the propagation time, right? So 17 into 10, this is the propagation time for ACK. Now, if you calculate all of this, you will be getting 40.8 milliseconds, right? So you will be getting, for one packet, you will be getting 40.8 milliseconds. Since there are 1000 packets, right? Sorry, there are 100 packets. If you just do it for 100 packets, then you need to multiply by the 100. So 40.8 into 100, these milliseconds you will be getting. So this is same as, I think, is the answer matching here? So this is same as 4080 seconds, milliseconds. 50,000 is there, and 500 is there. So I think if I just divide by 500, so 100 packets are there, right? So you will be multiplying by the 100. So 108408. Okay, so again, there is a mistake here. This is 408 milliseconds. Okay, sorry. So this is 408 milliseconds, not 40.8. Someone has actually commented 40.8, I think. So I read it and I have not solved it. So yes, so it is 408 and then it will be these many milliseconds. So I think this B is the correct answer. Okay, I'm sorry about it. I have not done the calculation. So I was just, believing in one of the comment. So that is why I think that was the mistake. So I'm sorry about it. So yes, 40.8 is the correct answer here, right? Okay. Now let's just solve this question. This question was nice and interesting. Okay. This question was interesting question. In this question, they are saying that you have a UDP datagram with a payload size of 4408 bytes from the office machine to her home machine. 4408 is the size of the application data without UDP header. So you will be having UDP header, you will be having IP header, right? That is what sender is having, and then 4408. Okay, this is at sender size, sender side. Okay, now sender is sending to the receiver, and at the receiver side, what you are having? See, notice that packets comes with the IP fragment at home. See, notice something strange. Packets arrive as 3 IP fragments. Okay, so basically it is getting divided into the three fragments, which is fine. Now, do you know how to divide? So you will be keeping IP as separate. See, this is very interesting. If you have IP, you have UDP, and you have 4408, right? Now, if you divide into 3 parts, there will be in one of the packet, okay, whatever you call is the first packet, IP actually will be everywhere. Okay. In one of the packet, you will be having, just in one of the packet, you will be having, basically you will be dividing this, right? In just one of the packet, you will be having UDP and some data. And this is actually some data. This is some data. Now, interestingly, in just one of the packet, you will be having UDP. Okay. So UDP will not be in 3 packets. That's the catch of this question, right? That's the catch. UDP will not be in 3 packets. Now, what they are saying is that each delivered fragment is exactly 1500 bytes, including IP header. So this is 1500 bytes. This is 1500 bytes. This is 1500 bytes, right? Originally, the data is anyway 4408. So basically, 4500 you have actually received, right? This is the received. Out of this, you have if you subtract 4408, right? So from 4500, if you subtract 4408, you will be getting 92. So basically 92 bytes you are having here, and my 92 bytes is comprising of 3 IP and 1 UDP. Okay, so 92 minus 1 UDP, right? I mean, this 92 is comprising of 3 IP and 1 UDP. So 90 minus 1 UDP. So UDP is given as 8 bytes of header. So basically it will be 84 bytes, right? So this is 3 IPs, 3 IP headers, right? So 84 divided by 3, right? So 84 divided by 3 will be the answer. Okay, 28. So 20 it is correct answer here. Now some people are saying that how to know that they are asking about the total IP headers. So see here, I'm just saying IP header size. Okay, not headers. I'm not saying headers. I'm just saying header size. So it means they are only asking about one IP header. So 28 is the correct answer here. So yes, this was a nice question. Okay. Okay. Calculate the IP header size, right? So in examination, if they ask you calculate the total IP headers size, then it will be 84, right? Okay, just be careful that what they are asking in the exam. And also in this particular question, this was the case that UDP is only at one place, not at 3 places. By the way, there has been gate question which they have asked, which was using the same concept. Let me just tell you that gate question also. Okay, which was also using the same concept, where we have to actually be careful about the UDP. Let me just tell you. Okay, so in this gate question also, if you solve this gate question, then you will realize that this gate question and that question is actually, somewhat similar. Okay, somewhat similar. Now let's see this question. How many of you were able to solve this question? This was extremely nice and very challenging question, I can say. For now it is challenging, but after the solution it will be easy. How many of you were able to solve this question? Let me go through the concept of this question first, and then you will appreciate the beauty of this question. By the way, this question I've already solved. I mean, this kind of questions I've already solved in the class. So how many of you, if you have seen the lectures, then you know this. How many of you have seen the lectures? Okay, some people are saying CD as the answer. Let me first tell you the answer probably, and then we can go to the answer. Yes, CD is answer. Great, great. I'm really amazed to see that many of you people have got it correctly. That's really interesting. Okay, so how you did it? How you did it? I mean, because this question was challenging. Okay, I thought that it will be very challenging to you guys. But yes, many people are saying CD is answer. How you did it? Have you seen the lectures? Have you seen Go Classes lectures? How you did it? Have you seen class lectures? Tell me. Oh, that's amazing that many people are saying CD, right? Many people are saying CD. Wow, nice. Many people are saying CD. So how you did it? Can you tell me quickly? Okay. So see this question. What this question is saying? They are saying that you have T1, T2, T3. So by the way, how does the lexical analyzer work? Maybe I can quickly tell you about it, and then I can start solving this question. Maybe I can just take the screenshot from class notes directly. Okay, let me just take the screenshot from class notes, and then I will tell you. See, this is potential gate question, by the way. Okay, this is potential gate question because from the lexical analysis they have not asked these kind of questions. Okay, this is definitely potential gate question, I can say. See, suppose you are having the lexical analyzer. This is slides from the class. Okay, so if you have seen this lecture, it is fine. Otherwise, it will be revision. I mean, if you have not seen it, it is also fine. If you have seen, this is also fine. Okay, suppose these are the three rules you have. Okay, rule number one. Let's suppose rule number two, rule number three. Suppose you have a string which is basically having a b a a b. Okay, a b a a b. Now, what you will do with this string? You will start checking. Okay, a, then okay, you will go to next b, then you will go to next a, right? So now you know that okay, you can match with this rule 2, and then you can say okay, t2 is answer for this. But okay, sorry, once you match this ab, right? Once you match this ab, you know that okay, it has matched, and now you can say t3 is answer for this, right? But you know that it is possible that you can match with something else, okay, in future also. So that is why you can keep on going, and then you realize, oh, t2 may be the final answer, and then you will forget about t3. I mean, now you no longer worry about this T3, right? I mean, you could have assumed that okay, T3 is the final answer, but now you are saying that okay, since it is also matching with T2, so T2 is the final answer. T2 is probably the final answer, right? Okay. Now, but you will say, okay, what if it is matching with someone else, right? Now you will go to A, then you will be greedy and you will say that, okay, what if it is matching to T1? And then you will keep on saying, and at B you will realize, oh no, it is not matching with T1, right? So at this particular moment, you will realize that it is not matching with T1, and then you will backtrack to the moment where you last identified it, right? So this is backtracking, and then you will again start from A, right? So you will say it is T2, and then you will again start from A. Right? Is this fine to everyone? Yes. So some of you guys are saying, yes, Go classes lectures. So they have seen Go classes lectures, right? To solve this question. So have you understood this? That what is happening? See, you keep on going since it is maximal munch. So that's why you will be keep on going because you want to match with the maximum, right? You want to match with the maximum. So you realize okay, ABA is answer, but you will hold on it, and then you will match with A. Then you will say okay, maybe let me have the maximum munch, and then at B you realize okay, it is a fall, right? Since it is a fall, you will go back to whatever you last matched, and then you will say it is a backtrack. right? It is a backtrack. Now let's just solve this question. In this question, they are saying you are having x, you are having 4 times x, and then you are having 4 times multiple of 4x and then y, right? So you are having, if you are having x, then you will definitely say that there is nothing after it. So you will match it, and then you will say that there is no backtrack required, right? There is no backtrack required here. And if you are having, let's suppose 8x characters, and then you are having y, right? In that case, what will happen? You will say that, okay, these are the 8x, right? Then you will keep on matching, 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 and at y you will realize, okay, it is actually match. I mean, see, at x you could have said it is t1, but you know that, okay, what if it is not t1? Then you will keep on matching. After 4x you will say, okay, this could be t2, right? After 4x you can say this is t2, but you will go to the fifth x, and then you will keep on doing, but there is no backtrack required here, right? Because finally it will be success, right? Finally it will be success. There is no backtrack again. Okay. Now at this particular moment, you will at 4x you will say, okay, maybe 2, but you will be greedy and you will keep on doing, keep on doing, keep on doing. At 12x, okay, even at 13x, I mean at 12x even you will say, okay, maybe it is t3. At 13x also you will say, okay, maybe it is t3, but the moment you get y, it will be a major setback for you. You will say, oh, I made a mistake. Okay, you will backtrack to the moment you realize it was t2. So you will backtrack to the fifth x. So there is a backtrack required here, right? What about these 2x? You will realize, okay, this is t1. I mean, this 1x is t1. But what if there is a maximum munch? So that is why you will go to this x. Then you will realize that, okay, this is the end of the input, and then there is nothing is matching. So you will backtrack, and then you will say that, oh, let me just start from this x again. I mean, this is basically t1, and then this is actually t1. I mean, you will again recognize it as t1. You will backtrack and recognize this as t1. So that is why C and D are the correct answers here. Okay. Okay. So that's really great. So Murad Alam is saying that I have got 75 and rank 34 um, in this particular. Okay. So result is, by the way, just out. Okay. So congratulations who has got top rank. And don't worry if you have not got top rank. Probably your marks has increased. At least you have learned something from this particular mock test, right? So don't worry about the rank and all, because you never know that what gate has for you. Maybe in gate there will be the questions that you will be able to solve, and at least if you have patience for remaining 25 days, then you will be basically getting good result only because of the patience. Okay, only because of the patience and only because of the hard work you are doing. Okay, so maximum marks are in this. Okay, maybe I can just some of the attempts are not submitted, but that's fine. So we will regenerate the result, but most probably the marks maximum, I mean top 100 will not be changing. So maybe 200-300 were not submitted. So I've just submitted them, and then we will regenerate the results, but that's fine. Okay, so let's move to the next question. So what was the current maximum marks? It is 88, which is fine. Okay. Okay. Now let's just move to the next question. So what was the answer of this question? This was easy question. What was the answer of this question? Not very easy, but yeah, this was a nice question. So this question, I think there are a couple of questions we can solve, right? Okay. So what was the answer of this question? So in this question, they are saying that you have n jobs to run, and then jobs are arranged such that T1 is, I mean, the first job is having the lowest completion time or lowest burst time, and so on, right? Now, what is the order in which you should be running such that your average completion time should be minimized? So it means you want to complete at first as possible, right? I mean, you want to complete as soon as possible. So that's why you will be running J1 and then J2 and so on, right? I mean, here the preemptive algorithms like round robin or these things will not work, because it will only increase if you're preempting. Let's suppose you are selecting J1. If you're preempting J2, okay, and then J3 and then J2 or something like that, right? Then definitely, I mean, or maybe J4. So basically, your Anyway, time of completing this J2 is increasing, right? Why you want to increase? So obviously you want to finish as soon as possible. That is why the shortest job you should be running the first. So A is correct answer here. This is easy question but nice. These kind of questions get definitely asked, right? Definitely get asked these kind of questions, which are easy but nice questions. Okay. Wow. Great. So let me first verify whether it is correct or not. Yes. So Surojit Panja, yes, he has got rank one. So many congratulations for AIMT 3 rank one. So he has got rank one with 88.3 marks as of now. Maybe there are like 100 submissions. We will submit it. Okay. There are unsubmitted submissions. So we just need to click on submit button. 100 and 200 I think. Okay. But those are generally doesn't impact top 100 ranks whatever the remaining submissions are there. So congratulations. Okay, that's really nice. So many congratulations for such a nice rank and such a great marks. Great. Now let's see this question. In this question, what they are saying, consider a system with 6-bit virtual address and 16-byte pages or frames, right? The mapping from virtual number to the physical numbers is basically if you have virtual, let me just make a table, virtual page number 8, 1, 3, 2, 11, right? Okay, and 3, 1. So this is virtual page number, this is physical page number. Okay. So they are asking that if you have virtual address 20, then it will be mapped to which physical address. Okay. So if you have virtual address 20, then you can basically what you can do, you can tell me first, since it is 6-bit virtual address and 16 byte is the size, right? So can you tell me the virtual page number? Okay. So basically you will say virtual page number 0 and it will be virtual page number 1, right? It will be virtual page number 1. So virtual page number 1, right? If address is 20. So physical page number is 3, right? So physical page number is 3, which means physically it will be 0, 1, 2 and 3. So how many pages are above it? 3 pages, right? So physical page number is 3. So 3 pages above it and each is having 16 byte. So 48 bytes above it at least. And then how much is the offset? Offset will remain same, right? So offset here is basically 4 bytes, right? Because it is 16 bytes and is the page size and this is 20. So offset is a reminder basically, right? So 4 bytes. So basically plus 4, it is 52. Are you getting my point? What I'm trying to say? See here, this is 20. 20 is the virtual address. If virtual address is 20, it means that we have this is logical address space. Okay, let me just tell you. See, this is logical address space. This is virtual page first, I mean 0. This is virtual page 1 and so on. Okay, this is page 0, page 1. If you are having 28 address, 20 as an address, which means these are the 16 bytes, 17th byte, 18, 19 and 20. I mean basically you are talking about this particular byte. Okay, this is 20th byte. Okay, or the byte number 20. And then this is the physical address space. Now this virtual page number 1, as we know, it has been mapped to physical page number 3, right? Because of this mapping, which is given in the question. Okay, see, this is given in the question. Now, which is physical page number 3. Okay, 0, 1, 2 and 3. So this is physical page number 3 and this is actually loaded here. This as it is, okay, this whole thing as it is loaded here. Whole thing as it is loaded. Okay, so basically you will say that you have 16 into 3, 48 bytes above it, and obviously since it is as it is loaded, so after 48 and 4 bytes more, so 48 plus 4, which is 52. Okay, 52. Understood? And you can also solve this question definitely using binary. So let me first tell you let me also tell you using the binary. By the way, have you understood this? You can also solve the same question using the binary also. Okay, so 6-bit is given as virtual address, right? So what does this mean? Let me know. See, 20 is 0, 1. See, let me tell you. 20 is 0 1 0 1 0 0, right? So you will say that okay, 6 bit is total virtual address, 4 bit is basically offset, and this is page number. So page number is anyway 1, and we also got as 1. I mean, using binary, you can also say it is 1. Now page number will be translated to 3, right? Which means it will be translated to 1 1. The offset will be as it is, which is 0 1 0 0, right? This is the translation. Okay, this is the translation. Now if you convert that to again decimal, it will be 52. Okay, you can do this way also. Okay, you can do this way also. Okay, you can do this way also. Great. Now, what is the next question? They're also asking for the 40, right? They're also asking for the 40. So again, you can do in the same way using decimal or using binary. Let me do in both the ways, or maybe one of the way. Okay, using decimal, if it is 40, then if you have the remainder, it will tell you the offset 16, right? So 8, right? So 8 is the remainder, so it is offset, and 2 is the quotient. So basically it is virtual page number, right? It is virtual page number. So the physical page number will be 11, right? I mean, because of this mapping. Okay, so it will be 11. So it means your byte number will be 11 into 16 plus 8. Offset will be remaining same. Okay, so what is 11 into 16? It is 176. Okay, 176 plus 8. So what is 176 plus 8? It is 184. So 184 is the answer here. Have you understood this? So this is 184. Okay, so A and B are the correct answers. If you want, you can do this question. I mean, the next question, which was this question, in the binary also. Okay, I mean, you can do in the binary also. It's not an issue. So for the binary, okay, using binary, let's just quickly do it. This 40, you can represent this 40 as I mean, in the 6 bits, okay, because it's a virtual page number. It is 10 10 1000, right? Now this will remain same, and this 10, or not 10, I mean, this will be 2. This will be replaced by 11, right? 11 means 1011, 1011, and the offset will remain same. Okay, offset will be 100. If you convert this whole thing into the decimal, then you will be getting 184. You can do it. Okay, so you can do in both the ways. Okay, great. Now let's just move to the next question. This was again a nice and interesting question. This was a nice question. This was a nice question. Okay, so what this question is saying, by the way, this kind of question has been asked in gate also, I think, right? So wherever you have true loop, or at least like about the one loop, right? I mean, for the one loop, if you want to have minimum, then what to do, right? About the one loop, but have you solved the questions where you have two loops and you want to know minimum? See, the maximum will be, you will be having 5 increment here, and you will be having plus 10 increment here, right? So maximum will be definitely 15. So A is definitely correct answer. Okay, but what could be the minimum here? That is the interesting point. Do you know the minimum? How to solve for the minimum? So correct answer is A and B. Okay, correct answer A and B. Sorry, A and D. Final value of x is greater than. What is the correct answer? Okay, minimum is 3. Okay, cannot be 1, cannot be 2. Yeah, A, B, C, D. Yes, correct answer is A, B, C, D. Yes, all are actually correct here. Right? But how to solve for this question? How to solve for this question? See, maximum is easy. Minimum is little tricky. Okay, let's just see the minimum. Okay, one similar question has been asked in gate. That is why I have given this kind of question also. Okay, by the way, this question is from Stanford, and this question is very, very good question. Let me tell you how to know the minimum. For the minimum, what you need to do, you just this these kind of things, right? This is I mean, it will be first loading into the register, I mean reading, and then updating, and then loading, right? So it is read, update, I mean actual do the increment, add or something, add, and load, or maybe write, you can write, or store, or I mean read is basically load, store, add, right? So something like this. Okay, so these are the three instructions that you have instead of x equal to x plus 1, because x is a shared variable, then only that is why I'm interested only in this. Now for the minimum, what you need to do, very interesting. Okay, you just read x value initially. What is the initial x value? As you can see from here, x is initialized as 0. Okay, so x equal to 0 initially, right? Now what you do, you just waste all of this. Okay, now interestingly, if you waste all of this because of x equal to 0, you just keep it reading. Now you will say that okay, minimum is 5. I mean minimum is 5, you will say, right? If you waste all of this, right? I mean you can just execute all of this, and then finally you update with this, right? So you will say okay, minimum is 5, but there is a nicer way to do it. I mean you can get even lesser than 5. How? Interestingly, don't exhaust all of this. Okay, always do this thing in these two loops. Always exhaust one lesser than this. Okay, so last update, okay, x equal to x plus 2, or sorry, last read. So basically last x equal to x plus 2, first you have to read, add, and write, right? So this is the last thing. Okay, just do not even read it. Okay, do not even read it. I mean just keep holding on it. Okay, hold, I mean waste 4 of this, but hold on last one. Is this okay to everyone? Then what you do, okay, that's very interesting, by the way. Then you increment this by 1. Okay, always keep 1. Okay, always keep 1. Now you increment this. Okay, now you run this. Okay, now you update this. You always you do the x equal to 1. Okay, now x is 1. Now just hold on this one. Now only read. Now don't perform anything else. Now only read. Okay, only read x equal to 1. Okay, so read this next minimum. Okay, first you have read x equal to 0, you have wasted 4, and now you read x equal to 1 now. Okay, now you waste this remaining. Okay, whatever you are doing, you do this, doesn't matter, right? You completely waste all of this. Now x equal to 1 you have read. Now 1 plus 2, which is, I mean 3. Okay, so ultimately you will say okay, 3 is the minimum. Okay, so basically the sequence is something like this. I have written the complete sequence nicely. In the solution you will find it. Okay, so basically you will say thread 2 will read 0, and thread 1 will waste all of this. But in thread 1 also, you will just, okay, I mean they are calling it this thread 1 or 2. Okay, I think they are wasting for this, but that is fine. You waste one of this, right? That is fine. So I hope you understood this, right? Or you can read from this also, that you are wasting, and then you read. Okay, they're reading x equal to 2, which is fine. I mean basically they are I'm actually wasting 4 of this, and then just reading x equal to 1, but they are doing in the reverse way, which is also fine. Okay, but I hope you understood this solution. Okay, that's very interesting and very wise solution. Is this okay? Is this okay to everyone? This was very interesting question. How many of you were able to solve this question? See, let me again explain this. You just read x equal to 0, okay? And then you waste all of this, but keep only 1. Now now at the last you read x equal to 1, okay? You update it once, and then you read x equal to 1, then waste all of this, and then update this. Okay? Very interesting. Yes, it was a hard question. Okay, it was the hard question, but you should know the way to solve these kind of questions. Okay, you just keep one of this, keep one of this. Okay, and then you waste all of, keep the last one, and last one you do what for the last one? Obviously, the benefit of keeping the last one is only when you are making use of x equal to 1. For the last one, make use of x equal to 1. Right? Yes, AIMT 4 and 5 will be there most probably. Okay, don't worry. Okay. So now let's just see this question. A system is supported with virtual memory. Consider two statements below. Two processes reading from the same physical address will have the same content. That's very, very obvious. If the physical address is same, then they will be having the same content, because ultimately data is loaded in the physical address. Two processes reading from the same logical address will access the same content. If they are reading from the same logical address, will they access the same content? See, logical address is basically logical. I mean, see, virtual page, let's suppose someone is reading from 12, I mean, this is logical address space. This is the logical address 12. This is also logical address 12, okay, for some other process. Now, page table will be mapping this 12 with something else, some other physical address. It can map this 12 to some other physical address, right? So, they could be mapped. The logical address could be mapped to different physical addresses. So that is the reason. I mean, these are the two processes that can have 12 logical address, but this 12 logical address or this particular page will be mapped to some other physical address. This will be page mapped to some other physical address. So S1 is true, but S2 is false. Okay, only S1 is true. Is this understood? Okay, let me know. What is lower and upper? Okay, I hope this is understood, right? Great. Now let's see this question. This is easy question. You can write a v1 minus v2 equal to 0. It means that you have, the eigenvalue is 0, right? So ax equal to, basically, you have 0 into x, right? So one of the eigenvalue is 0. So at least one of the eigenvalue of a is 0. If that is the case, then a is not a full rank. It means columns of a are linearly dependent actually, right? So if they are writing independent, so that's why it is false. The determinant of a is 0. Yes, that is also true. So that was easy question, right? You just need to do a v1 minus a2. How many of you were able to solve this question? How many of you were able to solve this question? Okay, so in this question, if you have any doubt in this particular question, see this statement always, okay, whatever assumption you have, is this always true? Okay, I mean, for particular case, let's suppose you are saying, okay, it is true. Okay, for particular case, you are saying, because they are, I mean, some people are arguing, maybe like, let's suppose they're sharing the page or something like that. But is this always true? Or there are, some people are arguing that, okay, is this happening the same time or not? But whatever assumption you are making, or with whatever assumption you are answering, is this always assumption true? Okay, see, for S1 you can say it is always true, but can you say that for S2 it is always true? Just see that. Okay, okay, so this question also very easy. Okay, in this question they are asking probability of, student knows the answer, given that it was correct. They were asking this, right? So it was same as C intersection K divided by probability of C. So C intersection K means, I think, C and K, right? I think this one, which is 2y3 into 1. So it is 2y3 into 1 divided by 2y3 plus this one, okay, PC. Correct, right? Correct these two. 2 by 3 plus 1 by 12, okay? So if you solve this, you will get the answer. I think 8 by 9 was the correct answer here. Okay. 8 by 9 is the correct answer. Okay, so let's solve this question. I think this is the one of the last question from my section of the questions. So let's see this question. This was, I don't know, should I call it easy or not? But have you solved this question? Have you solved this question? This question that we ask in AIMT is almost same as this question. I think I only changed one thing. Yeah, I only changed this. See, here I have written a dot s. Here in the original question, it was a dot I. Okay, I only changed this particular thing. Otherwise, everything is same. Okay, so if you have solved this question, probably you will get, you know how to solve this question. But still there is a chance that you don't know how to solve this question. See, there is a common confusion. I will just clear out this confusion, right? So see, they're asking about the L attributed definition, right? That which one is L attributed. Here, what is the L attributed? Can you tell me what is the L attributed definition? Okay, so maybe I can just tell you. Let me just put the screenshot of L attributed definition from Ullmann. Okay, so just give me a second. Actually, in the lectures we have already discussed these things. So in the lectures it must be there. So maybe I can just directly go to my lecture. Okay, so I think in the compiler design there was one of the lecture. Okay, in that this definition is given, right? So this is a screenshot of goclasses lecture, and this particular slide is from Ullmann. Okay, so this is from Ullmann. So what they are saying about the L attributed definition? So they are saying that for given this production, the attribute of the symbol. Okay, so for these attributes to the left of xj, uh, just a second, the syntax is L attributed if each inherited attribute of xj on the right hand side depends only on, so inherited attribute of xj, right? So xj inherited attribute should depend only on attributes of xi to xj minus 1. So which means any type of attribute of xi to xj minus 1, right? I mean, they're not writing that whether it is inherited or synthesized. So xj should depend on any type of attribute of this, but only on inherited attribute of a, right? If it is depending on synthesized attribute of a, then it is not L attributed. See, it can depend on parent attribute, but parent attribute cannot be synthesized. That is the most important point for the L attributed. So they are saying parent attribute has to be inherited. So see here that for this particular thing, okay, for this particular thing, right? If Q is depending on A, that is fine, but it has to depend on inherited only. If it is depending on synthesized attribute of A, then this is because of this particular thing, it is not L attributed. Okay, it has to be inherited for the L attributed. Okay, see, suppose let's just first solve this question. Okay, let's just first solve this question. Is this L attributed? So its inherited attribute, P inherited attribute should depend on, okay, A inherited attribute. Yes, that's fine. So there is no problem with this. Q inherited attribute depending on any type of P attribute. Here it is inherited, it is fine, but inherited of A only. So yes, this is also fine. A synthesized should be depending on these attributes. I mean, so this is also fine, right? I mean, for synthesize it's not an issue, right? So I think rule 1 is not violating anything. What about rule 2? X inherited is depending on Y. Okay, so that's why it is not L attributed. So rule 1 is not violating anything. So you can say only rule 1 is L attributed, right? Because rule 1 is not violating because this is inherited. But what if this is synthesized? See, because of this reason only, this Q inherited should be depending on P, any type of P, but A inherited only. Okay, so any type of P, which is fine, but A inherited only because of this. Okay, because of this particular thing. Okay, this, it is not L attributed. Okay, see, it should depend only on inherited attribute of A. This is very important concept. Okay, this is very important concept. Have you understood this? How many of you have understood this concept? Let me know. How many of you have understood this concept? Previous year AIMT questions are mock test, okay, of Go classes. So these are the mock test of Go classes actually. So if you want to understand this concept, okay, just read this slide. Okay, just read the L attributed definition. Just pay attention to this line that it should be depending on inherited attribute of A only. Okay, xj should be depending on left, which is fine, but inherited attribute of A only. Okay, so inherited, I mean any attribute of xj minus 1, x1 to xj minus 1, but inherited attribute of a only. Okay, not synthesized. So I have just modified from, because I've noticed that they have given the inherited. I've taken the exact same question, but I have just modified this. Okay, just to make sure that you understand this concept nicely. Okay, is this understood to everyone or not? Okay, great. So that is all. This is part one of the discussion, and then we will be having the part two also. Okay, we will be having part two, which will be taken by Deepak sir. Let me know how was your experience regarding AIMT 3. Let me know if you want AIMT 4 or not, right? AIMT 4 and 5. Okay, just let us know. In the comments, just put some nice feedback. If you have enjoyed the AIMT, just put some nice feedback. Put the feedback about the concepts you have learned. Okay, concepts that you have learned from this particular session and from this particular AIMT. Okay. So thank you everyone. Thank you so much. Take care. Bye bye.